Chapter 2, Thermochemistry, Concept of Enthalpy. At the end of this chapter, students should be able to explain endothermic and exothermic reactions using electron-complete energy profile diagram. B. State standard conditions of reactions and define the following terms: enthalpy and standard enthalpy. C. Define and write thermochemical equation for each of the following enthalpies: formation, combustion, atomization, neutralization, hydration, and solution. Concept of enthalpy. Enthalpy is the heat content of a given system at constant pressure. The absolute value of enthalpy H cannot be measured directly, but enthalpy change of a chemical reaction can be measured. Enthalpy change, delta H, is the amount of heat absorbed and released by a system in a chemical reaction. It is used to quantify the heat flow into or out of a system in a process. Consider this following reaction. This diagram shows energy profile diagram of endothermic reaction. In the graph, we see that the reactants has lower enthalpy compared to the product. So as the reaction progresses, the product gains more heat or enthalpy. Another type of reaction is called exothermic reaction. In this type of reaction, the reactants have more enthalpy compared to the product. So as the reaction progresses, the reactants will lose enthalpy or energy to the surrounding as it turns into products. To sum up, exothermic reaction is called exothermic reaction because exo refers to outside, thermic refers to heat. On the other hand, endothermic reaction, endos refers to inside, thermic refers to heat. So this means endothermic reaction, heat is taken into the system, whereas exothermic reaction, heat is given out to the system. The symbol delta H for exothermic reaction will have negative value or has value less than 0. On the other hand, delta H of endothermic reaction will have value of higher than 0, or in other words, delta H is a positive value. In summary, products of exothermic reactions are more stable than its reactants because it has lower energy compared to the reactants. For endothermic reaction, the products are less stable than the reactants because the product has more enthalpy compared to the reactants. Enthalpy of reaction. When an enthalpy change is associated with a chemical reaction, it is called enthalpy of reaction. There are 4 factors that influence the value of enthalpy of reaction or enthalpy change. These factors are temperature, pressure of gaseous substances, concentration of solutions, and physical state of reactants and products. Standard enthalpy change refer to reactions done under standard conditions and with everything present in their standard states or reference states. Standard condition in terms of temperature is 25 degrees Celsius or 298 Kelvin, pressure of 1 atmosphere or 101.325 kilopascal. For aqueous solution, concentration for standard condition is 1 molar. And finally, the most stable physical state of substance at 1 atm. For example, oxygen exists as gas at 1 atm and 298 Kelvin. Therefore, the stable physical state for oxygen is gas. Enthalpies of reactions. There are 6 types of enthalpies of reactions that you must know for this course. 1. Enthalpy of formation. 2. Enthalpy of combustion. 3. Enthalpy of atomization. 4. Enthalpy of neutralization. 5. Enthalpy of hydration. And 6. Enthalpy of solution or dissolution. Enthalpy of formation. Enthalpy of formation is the change of heat when 1 mole of a compound is formed from its element at their standard states under standard condition. For example, the enthalpy formation of water refers to the reaction where 1 mole of liquid water is formed from its element, hydrogen and oxygen at their standard states, which is the gaseous state. The amount of heat released when 1 mole of water is formed is negative 295.9 kilojoules per mole. Note, when you are writing one of these equations for enthalpy change of formation, you must end up with 1 mole of product. This means that you need to write fraction on the left side of the equation so that the right side of the equation will be only 1 mole. The standard enthalpy of formation of any element in its most stable state is 0. For example, gaseous oxygen has the enthalpy of formation of 0 kilojoules per mole. And so do other gases. For sodium, its enthalpy of formation of solid sodium is also 0 kilojoule per mole. Enthalpy of formation, delta HF, at standard condition can be used to calculate enthalpy change of a reaction provided that all the enthalpy of formation of all reactants and products are known. The formula is shown below. The enthalpy of reaction is equal to the sum of enthalpy of formation of all the products minus the sum of enthalpy of formation of all the reactants. Please note, the stoichiometric coefficient of products and reactants in the thermochemical equation must be taken into account. Let's consider this example. In this example, the standard enthalpy of formation of barium oxide is given as well as the standard enthalpy of formation of barium peroxide. Calculate the standard enthalpy change for the following reaction. Is the reaction exothermic or endothermic? By applying the formula, we know that the delta H naught, or the enthalpy change of the reaction, is positive 80.8 kilojoule. The reaction is endothermic because it has positive value. Enthalpy of combustion. Enthalpy of combustion is the heat released when 1 mole of substance is burned completely in excess oxygen under standard condition. For example, carbon, when burned completely, will produce carbon dioxide. Heat release is negative 393 kilojoules per mole. Methane, or CH4, when completely burned in oxygen, will produce carbon dioxide and water. Water is obtained when hydrogen is completely oxidized. The enthalpy of combustion is negative 892 kilojoules per mole. In this example, we will look at how to calculate enthalpy of combustion based on the formula we have discussed in the enthalpy of formation topic. The reaction is given, and from the reaction, we can calculate the enthalpy of combustion. The enthalpy of combustion is negative 1559 kilojoules. Enthalpy of neutralization. Enthalpy of neutralization is heat change when 1 mole of water is formed from the neutralization of acid and base under standard condition. In the first example, hydrochloric acid reacts with sodium hydroxide to produce sodium chloride salt and water. And the next equation is when sulfuric acid reacts with sodium hydroxide to produce sodium sulfate and water. Please note, in the thermochemical equation of neutralization, we always have 1 mole of water on the right hand side of the equation. The value of enthalpy of neutralization is different based on the type of acids and base related or reacted in the equation. For strong acids and base, the enthalpy change is around 57.3 kilojoules per mole, or heat release is around 57.3 kilojoules per mole. Other combination of acid and base will give different values, as shown in the slide. Enthalpy of atomization. Enthalpy of atomization is the heat absorbed when 1 mole of gaseous atom is formed from its element under standard condition. Delta HA, or enthalpy of atomization, is always positive because it involves breaking of bonds to free atoms from its molecule or lattice structure. Please note, enthalpy of change requires change in state. depending on the standard state of the element. What is important in this note is enthalpy change of atomization of noble gases are 0 because noble gases are already exist as atoms. Write the thermochemical equation for the atomization of fluorine, nitrogen, iron with the heat changes given in the example. So in this example, we'll see that atomization of fluorine involves half mole of fluorine molecule breaking up to form 1 mole of fluorine atom. The similar change occurs for nitrogen gas. For iron, solid iron is converted to gaseous ion in the process of atomization. Lattice energy. Lattice energy is heat released when 1 mole of an ionic solid formed from its constituent gaseous ion. Lattice energy always have negative values. The magnitude of lattice energy increases as the ionic charges increases, and it also increases as the ionic radii decreases. Enthalpy of hydration. Enthalpy of hydration is the heat released when 1 mole of gaseous ions is hydrated in water. Hydration is a process in which water molecules surround the cations or anions of a ionic compound. Water molecules are polar. Because of this, the partial positive ends of water are attracted to the anion and the partial positive ends of the water molecules are attracted to the cations. The bonding of water molecules to the ions is called hydration, and the ions that has undergone hydration is said to be hydrated. The formation of electrostatic attraction force between ions and water molecules will release energy. Therefore, the enthalpy of hydrogen is negative. The stronger the electrostatic force, the more exothermic the reaction will be. The electrostatic reaction becomes stronger when the charge of the gaseous ion increases, and the electrostatic attraction force becomes also stronger when the size of gaseous ions decreases. In this example, because the magnesium ion is smaller than the sodium ion, the enthalpy of hydration value of magnesium is more negative. Enthalpy of solution. Enthalpy of solution is heat change when 1 mole of a substance is dissolved in water to form a solution of infinite dilution. So in the dilution process, cations and anions in an ionic structure will be separated, and each cation and anion will be surrounded by the polar water molecules. Thank you.